Hey everyone, I'm just going to do a quick podcast for one particular question in your bookwork because I think it's so important because it does deal with the lab that you guys are about to do. So basically, the question comes from chapter 14, number 46. And if you go to that in your book, number 46 talks about some data that they give you, and you have to figure out based off of the data is the reaction first or second order. And then it says, what is the value of the rate constant? So a very loaded question just based off of looking at data. And I do want to remind you of one of the ways that you can analyze data to figure out whether or not it's zero, first, or second order. So just looking at the data, you're not going to be able to tell very much. So they give you time, and then they give you concentration of the C12H22O11. Okay. Alright, so let's just kind of check this out. So time is 0, 39, 80, 140, and 210. Concentration here is 0.316, and then 0.274, 0.238, 0.190. So it looks like it's definitely decreasing the concentration over time. Okay, and your job is to figure out if it's zero, first, or second order. So the only way that you're going to be able to figure this out, actually there's a couple different ways. One way would be to actually sit here and literally figure out the differences between each of these values and seeing if that difference is constant over a very specific chunk of time. In other words, we're talking about graphical analysis. Graphical analysis can be very difficult, just doing it by hand. But thank God for modern technology. Okay, we're going to be using Logger Pro, and in your lab you will also be using Logger Pro. So I do want to refresh your memory of some of the things that you can graph to determine first, second, or third order. So you always place time on your x, and you start off with just regular concentration. And if you get just a perfectly beautiful straight line when you're doing this, then you have something called zero order. The next thing that you're going to do to determine, and remember we're always looking for a straight line, wherever the straight line happens, that's whatever order is. So if it's a straight line here, you have a zero order. The next thing that you guys have to check is natural log ln of concentration over time. And if this is where you get a straight line, a beautiful straight line, well then it's going to be first order. And the last check that you guys are going to be looking at is if you still don't have a straight line, like it's still curving, then the last check that you do is 1 over concentration over time. And if this is where you have a straight line, then it's going to be second order. Alright, I did place some of this information on your class website, so let's take a look at that. So I placed this picture on your class website, and it just is a really, really awesome summary of all the different graphs and what they mean to you for zero, first, and second order reactions. So right here where it says plot to give straight line, this is what you're going to look at. If you get a straight line of just concentration versus time, then it's zero order. If you get a straight line of ln of concentration versus time, then it's first order. And then if you get a straight line of 1 over concentration versus time, then it's second order. And then note these right here. This will come into play here in just a second for part B of the question. It says, what is the value of the rate constant? So for zero order, do you see how the slope is negative k? First is also negative k, but then for a second it becomes the same as k. All right, so we'll take a look at that in just a second. So like I said, the best way to analyze this particular question is to attack it by graphical analysis. So we're going to be using Logger Pro. I'm going to show you how to do that. So I took the information from the problem and just plugged those numbers in. So I'm going to refresh your memory on how to do a couple of those quick tricks to make this work here for you. So I plugged in the data of just time and molarity, and what you can do is you can adjust this total value. A couple different ways that you can do that. You just click on it and manually enter a value. I think I'm going to start with 1. And then over here you can make this a little bigger, make it like 250 if you want. And if you don't like the way that it looks, you can continue to adjust. But there is also a auto scale for the graph. If you just want to click that, it automatically scales. Now, just looking at the data, you're not going to be able to tell whether or not there is a curvature for this particular data set. And the best way to determine whether or not you have a beautiful straight line is to click this button for a linear fit. So when you grab that linear fit, take a really close look at the correlation. Right now for this data, we have a correlation for the straight line of 0.9950. And you'll notice if you look really closely, you've got a couple points, a few of them actually, that are not hitting directly onto that line. Maybe I didn't do it right. Hold on. Let me highlight the data. Maybe that's what I need to do. I do apologize. That's what you have to do. You have to highlight the data and then do a linear fit. There we go. That's much better. Still the same value. And you still have some points stuck off. I always like to highlight my data, though, to make sure that I've got all the data highlighted. All right, so keep that in mind. The very first one had a correlation of 0.9950. That's going to come into play. Now what we want to do is we want to move on to the second half. We want to do the natural log of the y. So here in Logger Pro, what you can do is you go to Data, and we're going to say New Calculated Column. Okay, I'm going to do that. And this is pretty cool. What you can do is we're going to create a new calculated column. I'm actually going to name the column specifically natural log of y. Okay, and in the expression, click here, you have some functions that are automatically available to you. And look, there's ln. And from here, I can actually collect which column I want them to do. I want them to do the natural log of the molarity, so I'm going to click on molarity. All right, and now I'm going to hit done. And sure enough, if you can move some of this over too. Let's see if I can remember how to do that, so you can see all of your data here. There we go. CC stands for calculated column. If you want to change that, go to the options, and you can change the name of the column and stuff like that. But for now, we'll just leave it. But anyway, you'll notice that you don't see that data set. Like, it's not showing up on the graph. So there's a really sneaky way of making that show up. If you want to, you just click right here where it says molarity. I'm going to click there and change it to natural log y. And you're like, hey, where's my data? Don't forget, autofit. All right, so there's your data. Now what you can do is, I think you don't have to highlight your data. I think all you have to do is just go to the linear fit. And let's, oops, sorry. Just trying to move that over so I can see it a little bit better. Do you notice the correlation here? You never would have known this unless you actually used like a graphing program. That correlation jumped to 99.99%. So far it's looking to me as if this particular data set is going to be first order. But in order to be absolutely sure, you should probably run the next data set, which is the 1 over concentration versus time. So when I was using Logger Pro, I couldn't really figure out how to do the calculated set on this one. Hold on, let me just check something real quick. Yeah, I couldn't really figure this part out. So my best guess here would be to go to Data and go to New Manual column. And this one is going to be 1 over molarity. And we'll just go like this, mole -1 if you want, or we'll just go 1 over capital M. Okay, we'll hit done. And it gives you an option to actually go in and put in that data. So I already did the calculations, and let me just give you some of those values. For this first one, I got 3.16, then 3.65. Oop, I don't want to change that one. Whoopsies. 39. I forgot. You have to press down, the down button. Let's see, and then I got 3.65. 4.20, 5.26, 6.85. Okay, so remember what you have to do. You have to click on the Y, and now I'm going to switch it over to 1 over molarity. And then don't forget, you can auto scale. Here it is. All right, so let's see. I don't think you have to highlight. Let's go to best fit. All right, and the best fit actually dropped to 0.9923. So it looks like for us on this data set, on this problem, it looks like for us the best fit happened with the natural log over time. So we can say with certainty that this is going to be a first order reaction. Now for a first order reaction, look at what the slope is. Slope is equal to -k. again, slope is equal to negative k. So I'm going to switch back over here. If this thing will wake up. So let's switch this to natural log. Here we go. Oop, best fit. I lost it there. Okay, so what I'm going to do again is I'm going to get that best fit. And this time I'm going to look at the slope. Bring that over. The slope here was negative, right? 0.003674. But remember that the reaction constant is negative of that value. So it looks like the reaction constant is going to be positive 0.003674. And then it's really important when you provide the reaction constant to also provide the units. So if you forgot what the units are, go look back again at the guide that I gave you on the class website, because it actually has that on there. It's a beautiful picture. I love that picture. But just understand for first order that the K is going to be per minute. Okay, per minute for this reaction. So the answer is, if you want to use scientific notation, 3.67 times 10 to the negative 3 minutes to the negative first power, or just say per minute. All right, so I hope that graphical analysis problem really sets you up nicely for doing the graphical analysis that you guys are going to see in class tomorrow. All right, you guys, I'll see you tomorrow, and thanks again for watching.